Of all the small, bright objects in the night sky, there is one that particularly stands out against the morning and evening sky. It's Venus, aka our sister world. Venus has always been a part of human study and culture, going back to the earliest civilizations, but it wasn't until the last century that we began to understand what it is truly like on the surface. We now know that Venus is a burning, toxic world and nothing like Earth, but the two planets do share similarities, and one shared even more than that. Both planets are similar in size, mass, and composition, and both are made from the same materials and are relatively similar distances from the Sun. So why is it that Venus is such a barren, suffocated wasteland now, while its sister planet prevailed? Venus is one of 4 rocky terrestrial planets in the inner solar system. These rocky planets formed from the remnants of the cloud that gave birth to the Sun, with leftover atoms and gas sticking together to form dust and rocks. As these rocks grew larger, they eventually became large enough to be somewhat rounded by their own gravity, turning into planetary embryos, which were smashing together as they fell into position in orbit around the infant Sun billions of years later. For terrestrial worlds remain Mercury, Venus, the Earth, and lastly Mars. Of the 4 planets, Earth lies in the most ideal position around the Sun, in the so-called Goldilocks zone, where it's not too hot or too cold, allowing the planet to sustain liquid water on its surface. Venus, on the other hand, got too close to the Sun and became a scorched world of extreme weather, with surface temperatures that would melt zinc. Venus is the hottest place in the solar system, even hotter than Mercury, and like Mercury, it doesn't possess a moon or a satellite. It orbits at just over 100 million kilometers away from the Sun, closer than the Earth by about a quarter. When the planets align, Venus approaches Earth as closely as 40 million kilometers, practically our next-door neighbor. As it orbits, Venus rotates in the opposite direction to all the other planets in the solar system apart from Uranus. Planets tend to orbit and rotate along the same disk and in the same direction because of the motion of the rotating cloud that collapsed to form the system star. One thing that might counteract this resonance is a collision with another planet or planetary embryo. Such a collision might also explain how slowly Venus spins in this opposite direction. The planet is roughly the same size as Earth, but takes a full 243 Earth days to rotate just once, longer than it takes to complete a full orbit of the Sun. As such, its day is longer than its year. Venus shares many characteristics with Earth. Both planets have a thin crust, a molten mantle, and a central core. And because it is so nearby and luminous, it has been captured since records began. Venus is named after the Roman god of love and beauty, and is the only planet named after a female deity. In fact, Venus is more associated with femininity than any other planet. But not every civilization has fully understood the planet when addressing it. The Mayans, an early Mesoamerican civilization, knew it as Chakek, or the Great Star, on the belief that Venus was actually a luminous star and not a planet. Some civilizations even went one better and mistook the world for 2 bright stars. The reason being the nature of its orbit around the Sun. When Venus overtakes Earth along its orbital path, it flips from being visible at sunrise to being visible at sunset. As such, the ancient Egyptians, Greeks, and Romans all thought Venus was actually 2 separate stars, the morning star and the evening star, which the Romans knew as Lucifer and Vespa. Not everybody made this mistake. Some early civilizations did correctly recognize the morning and evening star as a single object. The earliest acknowledgement of Venus as a single object was made by the Sumerians, an ancient Mesopotamian civilization which existed in the Bronze Age between 4,000 and 5,000 years ago. A cylinder seal recovered from the Gemdit Nasa period, about 5,000 years ago, indicates that the Sumerians knew the object as Inanna, a Mesopotamian goddess associated with sex, war, politics, and justice. Another early artifact naming Venus as a single object is the Babylonian Venus tablet of Amisajuka, a record of Venus's movements which is believed to have been created over 1,500 years before the Common Era began. The Babylonians knew Venus as the bright queen of the sky. In the 1600s, Galileo studied the planet and discovered its orbital phases, which helped him to understand that the solar system was centered around the Sun and not around the Earth. But even as telescopes improved and we began to understand the planet better, we were unable to learn any more about its surface because we couldn't see inside. Venus is covered in a layer of reflective clouds of sulfuric acid in its upper atmosphere. This makes the planet brighter than it would usually be, but also blank and featureless. For this reason, Scientists debated for centuries what could lie on the surface, pondering everything from an ocean world to a full-scale inhabited world like our own. But in order to find out, we'd have to actually land on the surface and see for ourselves. Venus was the first planet we managed to successfully fly by with a robotic spacecraft, namely the U.S. Mariner 2 spacecraft in 1962. Then throughout the 60s and 70s, the Soviets began to get closer with the Venera program. In 1967, Venera 4 entered the Venusian atmosphere and showed that the temperature was much higher than previously thought. Venera 7 was the first successful Soviet mission to make it to the surface, and then over a decade later, Venera 13 made it to the surface of the planet alive and beamed back over 2 hours of groundbreaking data and the first pictures of the alien surface. Venera 13 revealed once and for all a hellish, tortured wasteland. Venus is today, with an average temperature of 462 degrees Celsius, by far the hottest place in the solar system. Its lower atmosphere beneath the clouds is a choking mix of 96% carbon dioxide and most of the remainder nitrogen, which is unevenly distributed across the planet's surface. The pressure is 91 times that of the Earth's surface pressure, thus the same pressure is found thousands of feet below sea level. As technology has improved, missions have been sent in the years since to perform radar mappings of the planet. Whereas visible light collected by normal cameras cannot pass through the thick clouds of the upper atmosphere, microwave radiation can pass through, and so we got our first surface maps. In 1990, the Magellan spacecraft began orbit around Venus and mapped the surface in great detail. It also detected extreme winds, abundant lightning, and then in 1995, a highly reflective substance in the higher reaches of the planet that is thought to be snow-like, but its composition is unknown. Venus has over 1,000 impact craters, all of which are at least 3 kilometers wide, meaning they were formed by meteors at least 50 meters in diameter. On Earth, a 50-meter asteroid would be enough to wipe out a city, but on Venus, any meteor below this size wouldn't even make it to the ground before being disintegrated on its approach. Furthermore, the vast majority of these large impact craters are in immaculate condition, no subsequent impacts or weathering. While Venus doesn't have any means of tidal heating, a discovery made in January of this year suggests young, fresh lava flows on the surface and spikes in sulfur dioxide. Venus is still a geologically active world. Much of the Venusian surface appears to have been shaped by volcanism. The planet has over 150 volcanoes, which are over 100 kilometers in diameter, and 80% of the planet's surface consists of vast plains caused by ancient lava flows. What this indicates is that the planet was completely resurfaced over 300 million years ago. All the volcanoes must have spilled over at once, cooling into vast plains and highlands, and like the impact craters, this landscape has been well preserved ever since. On Earth, plate tectonics drive the reshaping of the crust, but Venus lacks tectonic activity. So while the surface of the Earth is constantly being reshaped every 100 million years or so, on Venus it takes closer to 500 million years. Furthermore, this isn't a consistent or gradual process of convection currents. Scientists think that whatever heat is inside the planet's core rises up and heats the mantle, making it hotter and hotter until eventually it causes a global subduction event. The entire surface is swallowed up, resurfaced by lava, and hardens out again, where it remains for hundreds of millions of years before the process repeats. The rest of the planet's surface area is made up of 2 highland continents. One, Ishtar Terra in the north, is about the size of Australia and is named after the Babylonian goddess of love Ishtar. The other is Aphrodite Terra, after the Greek goddess of love, which is roughly the size of South America and lies just below the planet's equator. Even in its hostile, extreme present-day state, Venus is still a fascinating world, but it hasn't always been this extreme. In fact, this toxic desert planet may have once known its own Earth-like conditions. Back when the solar system was young, Venus may have been the place to be. The sun is a giver of light within the solar system, radiating energy as heat from its surface to each of the 4 terrestrial planets. Earth sits in a fortunate position, just the right distance from the sun to have sustained an atmosphere for billions of years. However, the sun hasn't always been at the brightness and intensity we enjoy today. As a star ages, it burns hotter, making it brighter, and the sun is no exception. 4 billion years ago, it was much younger and fainter, and so were its stellar emissions. At the same time, Earth was forming alongside its lost twin, Venus. Within a few million years of its formation, the Venusian surface had cooled, And unlike Mars, it was large enough to be able to retain its atmosphere. Venus's early atmosphere consisted of carbon dioxide and water vapor. This atmospheric layer protected and warmed the planet through the process of the greenhouse effect. These early atmospheric gases are transparent to visible light, so as light from the sun radiates outward, it passes through the atmospheric layer and warms the planet's surface. Then it hits the ground, and the heat is re-emitted as infrared radiation, which is absorbed by these atmospheric gases, so the heat can't escape back out into space. Gravity keeps the atmospheric layer bolted down to the surface like an all-encompassing blanket, which allowed the primordial Venus to retain just enough heat to maintain a temperate climate with a mild atmosphere. As the greenhouse effect maintained the planet's temperature, the water vapor in the atmosphere began to condense and form clouds, and then the downpour began. Like on Earth, it rained every day for thousands of years on the early Venus, and water flows formed streams, then rivers, then lakes, and then vast seas. Venus became an ocean planet, sustained by its temperate atmosphere and fortunate distance from the young sun. It's almost certain that life on Earth began in the oceans, perhaps in deep-sea hydrothermal vents. These vents are driven by geological activity and spew up minerals from the Earth's mantle, and the high temperatures and water mix the molecules which eventually gave rise to cellular life. When we visited Mars, another planet which may have enjoyed a spell as a water world, we found hydrothermal vents on its dried-up ocean floors as well. Mars would have had deep-sea vents and habitable oceans for a few 100 million years before it lost too much of its protective atmosphere to space. But Venus, on the other hand, being larger, would have been able to sustain its ocean for around 2 billion years. Given that Venus is geologically active now, it was likely geologically active back then too, meaning there may once have been bubbling hydrothermal vents at the bottom of its oceans which have now been lost by global subduction events. Given Venus's similarities in size and composition to the Earth, it's hard not to wonder about the possibility of the process of abiogenesis occurring on Venus as well as Earth. Perhaps chemistry played out on the Venusian sea floors as well, and perhaps Venus was once an inhabited world, like the legends foretold. If anything did live on Venus during this period, it likely wouldn't have been anything more than microbes. After all, it took several billion years before multicellular organisms evolved on this planet, as well as a series of global catastrophes and extinctions. Any life on Venus would have almost certainly comprised solely of single-celled organisms such as bacteria, but even that is a fascinating possibility. With life as diverse and widespread as it is on Earth, separate windows of opportunity for habitable water worlds on both Mars and Venus, and the speculated habitable conditions of moons like Europa and Enceladus, it gives you hope that extraterrestrial life may be common, thriving on rocky planets and moons throughout the entire galaxy, and maybe in galaxies beyond. So what happened to this lost oceanic kingdom? Well, the greenhouse effect continued to maintain balance on the planet for hundreds of millions of years. But during this time, the sun was aging and evolving. As it grew older, it burned hotter and became stronger, more intense. As this happened, more heat was being trapped under Venus's atmospheric layer, heating the surface and gradually evaporating the oceans. At higher altitudes, this vapor condensed and fell as rain again. But before long, the surface temperatures were so hot that the rain was boiling away before it even touched the ground. As the water vapor condensed in the atmosphere, it trapped even more infrared heat under the atmospheric layer, and an irreversible, vicious cycle had been set into motion. The oceans dried up, and the water vapor was gradually swept into space by solar winds and the lack of a strong magnetic field. All that was left were dry, scorched deserts, destined to be buried and resurfaced by volcanism, and the water world, and anything which might have inhabited it, was gone. So that's the past, and we know the present. But what about Venus's future? Well, Venus's extreme conditions in close proximity to Earth make it an intriguing world to study, but maintaining a presence on the surface of such a hostile world is a significant scientific challenge. In 2016, the NASA Innovative Advanced Concept Program explored the idea of the automaton rover for extreme environments, a wind-powered, self-controlled rover which could survive conditions of the Venusian surface for extended periods. The idea is still in the planning phase, but there are now hopes that the same concept could be applied to the exploration of Mercury. But then, perhaps landing on the surface of Venus is unnecessary, and the upper atmosphere might be a more reasonable target. While Venus is extreme on its surface, the temperature and pressure drop significantly in the upper layers of the atmosphere. 50 kilometers up, The pressure is similar to the surface of the Earth. Launching something into the upper atmosphere may just give us a shot at our close encounter with our sister world. Scientists have suggested launching aerostats, essentially extremely light balloons, which could enable us to maintain a permanent presence in the upper atmosphere and perhaps floating laboratories and manned missions one day. However, this kind of technology is still a long way off, as even without the crushing conditions of the Venusian surface, any hot air balloon would still have to be built to withstand high levels of sulfuric acid for sustained periods. Whatever we decide to do, we unfortunately can't get too comfortable, because the Sun is still aging and maturing, and the next stage of its life will prove catastrophic for Venus. As the Sun exits its main sequence, it will rapidly expand and cool, ballooning to more than 250 times its current diameter. When this happens, Venus and Mercury will be completely engulfed by the new red giant sun, and its story will be over once and for all. Venus's best days are behind her. Once an illustrious ocean planet, now a toxic ball of dry rock and gas, waiting to be devoured by a dying star. Venus once had all the qualities to be Earth-like, but ultimately it is just too close to the Sun to have sustained this. It's interesting and unsettling to think that the extra 25% further out we are from our Sun has made all the difference in the long run. Earth is truly a success story of the solar system, but Venus's story is still fascinating and probably more intertwined with ours than we yet realize. It's hard to imagine Venus any other way now, but who knows what events and phenomena might have played out in those 2 billion years when Venus was the Earth's true twin.